Welcome to section 421. We're going to be talking about transforming other graphs besides quadratics. Now to do this, we need our parent functions. Now I will make these available to you in a printout to make it easier. So what we're going to do is we're going to start with our anchor points. So our anchor points, those basic points for our parent function. So for y equals x squared, our anchor points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. These are the basic points. This is the basic shape and size of a quadratic, y equals x squared. For a square root, our anchor points. Because we can't take the square root of a negative number, we're going to start at 0. And then our perfect square, 0, 1, 4, 9. So our square roots, 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. That's the shape of a square root function. For a cubic, x and y, we can cube any number we want to. So we'll have a -2, a -1, 0, 1, and 2. When we cube -2, we get -8, -1, 0, 1, and 8. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So our cubic, looks like that. That's the shape of a cubic function. For D, this is a hyperbola. So because we're dividing, x cannot equal 0. We can't divide by 0. So I'm going to put some values in here. -10, -2, -1, +1, +2, +10. Just adding some extra values here. So it's going to be -1/10, -1/2, -1, +1, +1/2, and +1/10. So there. Now, it is a hyperbola. We have a horizontal asymptote and a vertical asymptote. So our vertical asymptote, x equals 0. And our horizontal asymptote is y equals 0. There's the right-hand side, and the left-hand side looks like this. So keep in mind, it has a horizontal asymptote and a vertical asymptote. The vertical asymptote, x equals 0. The horizontal, y equals 0. For an exponential, 2 to the x. I'm going to pick some values around 2. So -2, -1, 0, 1, 2, and 3. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1st is 2. 4, and then 8. So now, exponentials have a horizontal asymptote. So our horizontal asymptote is going to be right here at y equals 0. And then when we draw our graph of the exponential looks like that. Now it might change a little bit depending on what your base is. And then for y equals the square root of x. Picking some values around 0. Now, when you take the square root of a number, you're always going to get a positive. So the square root of -3 is 3, square root of -2 is 2, then 1, 0, 1, 2, 3. So square root functions have a V-shaped graph. This is a square root function. Looks like a V. Now, we're going to use this information and we're going to talk about our transformations. Like I said, I will be providing this as a printout for you. So the general equation of a function. Now, you've seen this before. We talked about it with our quadratic functions. Now the transformations, same thing applies. When the absolute value, when a is less than 0 there's an x-axis reflection. Now, when the absolute value of a is greater than 1, whether it's a positive 2 or a negative 2, positive 3, negative 3, there's a vertical stretch. When the absolute value of a is between 0 and 1, there's a vertical compression. Whether it's a positive 1/2, a negative 1/2, a positive 1/3, a negative 1/3. So that's all for the power of a. And then h, we shift left if it's a negative and right if it's a positive. K, we shift down if it's a negative and up if it's a positive. So there's our transformations. It should look very similar. We've done this before with quadratics. Now we're just applying it to other functions. The general form of a quadratic, y equals a times the quantity of x minus h squared plus k. The standard form of a square root function, y equals a times the square root of x minus h plus k. Notice how h for both of those is one in the parentheses, the other one's under the square root. The h is always inside that function and k is always hanging outside. A cubic, y equals a, times the quantity of x minus h cubed plus k. For a hyperbola, y equals a, 1 over the quantity of x minus h plus k. For an exponential, for 2 to the x, for example, y equals a times 2 to the x minus h plus k. H is in the exponent. You might also see it generically for y equals b to the x, y equals a times b to the x minus h plus k. And b is whatever your base is. For absolute value, y equals a times the absolute value of x minus h plus k. So what we're going to do now is using this, we're going to find our transformations and graph the functions without a calculator. So for number 3, we want to list a, h, and k. A is 2. H, be careful of your signs. It's not 3, it's a negative 3. Change the sign for h, and k is a negative 2. So when a is 2, that means we have a vertical stretch. H is negative 3. We're going to shift left 3 and then down 2. So I'm going to plot my anchor points, 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. Now we're going to take our vertical stretch first. I'm going to multiply my y coordinate of the points by 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. It's way off the graph. Same thing over here. We're at negative 1, 2. We're at negative 2, 8. And now we take each point and we go to the left 3 and down 2. So left 3, down 2. 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 And here, through those open dots, is where our graph is. And just real quick, our domain, all real numbers, and our range, y is greater than or equal to negative 2. There's our graph. There's our transformations. I got the anchor points from the previous page, which you should print out. Number 4. This is a hyperbola. So the parent function, y equals 1 over x. So now I'm going to plot those points. We don't have a whole lot of points to work with here. We have 1, 1, 2, 1/2, and those are really the easiest things for us to work with. So now, looking at our values, a is 1. H Watch your signs. It's not a 3, it's a negative 3. And K is a negative 2, which means nothing happens for A. There's no shrink, or stretch, no compression, and no reflection. So all we're going to do is we're going to shift left 3 and down 2. So I'm going to take this point and go to the left 3 and down 2. To the left 3, down 2. Go to the left 3, down 2. Left 3, down 2. Not only did our points move to the left 3 and down 2, but our vertical asymptote also moved to the left 3. Now it's at x equals negative 3. Our horizontal asymptote then also moved down 2. And it's at y equals negative 2. And then I could just draw my graph, making sure not to cross that asymptote. So there you go. So our horizontal asymptote, y equals negative 2. Our vertical asymptote, x equals negative 3. Our domain, all real numbers as long as x does not equal negative 3. And our range, all real numbers as long as y does not equal negative 2. Let's do a few more. On the next page, y equals x cubed minus 4. So our parent function, y equals x cubed. So my anchor points that I have on the handout already, 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. Now my values for a, h, and k. That's going to tell me my transformations. A is a 1. H, there's nothing in parentheses, so my h is actually a 0. And then k is a negative 4. When a is 1, nothing happens. No stretch, no compression, no reflection. H is 0, nothing happens. So all we're going to be doing is shifting down 4. So I'm going to take each point and move down 4. And then I can draw my graph carefully through those points. And there's the graph of that function without using a calculator. So the domain for this, all real numbers, and the range is also all real numbers. Now for number 6, the parent function y equals 3 to the x. So negative 2, negative 1, 0, 1, and 2. Here's my anchor points. They're just the powers of 3. 3 to the negative second is 1/9. 3 to the negative first is 1/3. Then 1, 3, 9. There's our values. Now, A, H, and K. This tells us where we're moving. A is 1. There's nothing in front of the 3 to the x minus 2. H is with the exponent. It's not a negative 2, it's a positive 2. And then K is a negative 3. So all we're doing, A is 1, but nothing happens still. H, that means we're going to shift right 2, and we're also going to go down 3. So I'm going to go to the right 2, each point, and down 3, put a little x. To the right 2, down 3, to the right 2, down 3, to the right 2, down 3, to the right 2, down 3. Not only did each point move to the right 2 and down 3, but our horizontal asymptote moved down 3. So our horizontal asymptote is located down there at y equals negative 3. So you can draw your graph through those points, and there we have it. Now for this, our horizontal asymptote is at y equals negative 3. It's shifted down 3 with k. Our domain, all real numbers, and our range, all our values for y are greater than -3. We're going to stop here, and I will see you in the next video for the remaining problems. Thank you.